Okay, router 1941. Okay, first configure the IP addressing. Okay. Now enter enable and configure terminal. Configure terminal. Gigabit 00. Set an IP address. You will use HSRP. For HSRP, virtual IP will be number 1. So for R1, I can use number 2. IP address 172.16.1.2. Subnet mask. Shut down. This another interface for the serial link serial 000. IP address 192.168.13 can be the number 2, 55 to 55 to 55 to 52. Prefix 30, no shutdown. Okay, the interfaces for R2. No enable configure terminal. Okay, don't forget the host name on the routers. Exit router R1. Host name R1 is to differentiate the devices. Host name R2. And this IP gigabit 00. IP address 172.16.1 can be number 3, 285 to 85 to 85 0. Shut down. The serial interface serial 000, serial 000, IP address 192.168.23 can be number 2, 55 to 55 to 55 to 52. No shutdown. And don't forget loopback 1. Interface loopback 1. IP address 10.10.3. Use the first IP 1 and subnet mask 24. Okay. And okay, don't forget the loopback on R1. On R1 interface loopback 1. IP address 10.10.1. Subnet mask 24. Exit. Okay, and on R2, configure this interface gigabit 01. Gigabit 01. Interface gigabit 01. But use sub interfaces. Sub interfaces for each VLAN 40, 50, 60, 199. So I will use the same number for the sub interfaces, the same number used in VLANs 40. Don't forget the encapsulation. .1Q 40 IP address. Okay, on this subnet, use the number 1. 172.16.40.1. Subnet mask 24, 50, 50, 50, 60, 60, 60, 199, 199 native. Okay, 199 is the native. $199, and enable the physical interface gigabit 01 no shutdown. Okay, very nice. And continue with addressing R3. Don't forget the host name. No enable configure terminal host name R3. Interface serial 000. IP address 192.168.13.1, 285, 285, 285, 252. No shutdown. This is another interface serial 001. Use the first IP because in the another side is the use the first IP 23.1 because the another side has the number 2. Okay, no shutdown. And serial 010. Serial 010. 34.2, the second, and prefix 30.252. No shutdown. Okay, very good. Now configure R5, R4, no enable configure terminal host name R4 serial 000. IP address 192.168.34.1, prefix 30.252. No shutdown. Okay, the network here, the connection to the ASA. The connection between R4, NAT, and ASA is not specified, so you can specify a network. For example, use 36. Okay, and configure gigabit 00. Gigabit 00, 36.1, 252, no shutdown. This interface CL 001. IP address 45.1, 252, no shutdown. Okay, I will configure the connection to Internet later, so go with R5. No enable configure terminal host name R5. Interface serial 000. IP address 192.168.45 and 285, 285, 285, 252. No shutdown. Gigabit 01. The connection to the another router, gigabit 01. IP address 172.16.56.1, 255, 255, 255, 252. Okay, it's 172.16.56.1. No shutdown. and this interface gigabit 00 with sub interfaces, because you will have 4 VLANs: 10, 20, 20, 30, and 99. So for 10, use the same number of the VLAN. Okay, the subinterface will have the same number of the VLAN under encapsulation.1q 10 IP address. And look at this subnet is 10.0. So use the first for the default gateway. So it will be 10.1. 172.16.10.1. 255.255.255.0. And 20. Okay, 20, 20, 30, 30, 30, sorry, 30, 99, 99 native. Okay, the 99 is native. 99.1, very good. And interface gigabit 00, not shut down. Enable the physical interface. R6. Now enable configure terminal hostname R6. Interface gigabit 00. IP address 172.16.56. 1 is R5. This will be 2. 255, 255, 255, 252. 172.16.56 2. No shutdown. And this gigabit 01. Gigabit 01 and 72.30 1 1 72.30 1 1 0. Okay, no shutdown. Okay, don't forget area 51 OSPF 1. Okay, this will use RIP version 2, this EIGRP 100. I don't know why this IP address is here. Should be removed because the VLANs are specified here. These are the networks for each VLAN. Okay, and so I will remove this. Okay, OSPF 0 area 0, OSPF area 0, OSPF area 50, OSPF area 51. So you can configure OSPF. Okay, first on R6, exit and router OSPF1, process ID number 1 and area 51. Okay, enter. Do show IP route connected. Now you can see the two directly connected networks. Okay, one for the connection to R5 and another for the connection to the LAN and advertisement network 172.16.50.60 and area 51 and 172.30.1.0 wildcard 255 area 51. Okay, and you can set the passive interface on gigabit 01. Passive interface gigabit 01. Okay, and ready. Now R5. Enter exit router OSPF 1. Do show IP route connected. Now you can see the directly connected networks. Okay, these are the sub interfaces 010, 020, 030 and 099. Okay, and this belongs to area 50. Okay, network. Okay, this first with this 172.16.10.0 wildcard for 24 area 50. Okay, area 50. And okay, it's network 10 20 on area 50, 30 on area 50, 99 on area 50. Okay, 1 2 3 and 4. Now 56 on area 51. Network 172.16.50.60 wildcard for 30 50.60 wildcard for 30 is 3 on area 51. Okay, and wait a moment for the network convergence. Okay, this is the adjacency with the router R6. Enter, and finally notify this the 45 that will be on area 0. Network 192.168.45.0 on area 0. Okay, the wildcard for 30 is 3 area 0. Enter. And set the passive interfaces and the interfaces on gigabit 00. Passive interface gigabit 00 dot 10 20 30 99. Okay, exit. Now configure R4 for NAT. Okay, and now first configure the connection to internet. Okay, gigabit 01. Enter, enable, configure terminal interface gigabit 01 IP address. Okay, an IP address on this subnet 209.165.200 prefix 29. 209.165.200. I will use number 2. 285, 285, 285, 248. This is 248 is for prefix 29. I'll shut down. Okay. And okay, the server will be number 2. So change the IP address here. Can be number 3 or number 1. Okay, interface gigabit 01 can be number 3. not shut down. Okay, very nice. And now configure routing, exit router OSPF1. Okay, do show IP route connected. Okay, 4 directly connected networks, 1, 2, 3, and 4. 4 directly connected networks. Okay, then advertise the 45 and 34 on OSPF area 0. 45 and 34 network 192.168.34.0 wildcard 3 area 0 and 45 0 3 area 0. Okay, very good. And I will use a static routing for the connection to ASA and a static routing for the connection to internet. Okay, and if you will use a static routing on gigabit 000 and a static routing on gigabit 01, you can set these interfaces as passive interfaces, because you will use gigabit 00 and gigabit 01 with the static routing and will not be part of OSPF. Okay, passive interface gigabit 00 and gigabit 01 and exit. Okay, create a default route to reach internet, IP route. This is a static routing, default static route, and use the local interface gigabit 01 or use the NAT hop IP address. Okay, I will use the NAT hop IP address. In this case is the server. Okay, the server will be 209.165.202. 209.165.202. Okay, if you will implement NAT on the ASA, you don't need a static route on R4 NAT. Okay, but I will configure that later. For now, I'm creating the default static route to internet, and propagate this default route on OSPF. So access to router OSPF1 default dash information space originate default. Okay, sorry, default. Okay, exit and go to R3. Enter enable configure terminal router OSPF1 do show IP route connected, 3 directly connected networks, 1, 2, and 3, and advertise on area 0 OSPF. Network 92.168.13.0 wildcard is 3 area 0 23 0 3 area 0 34 0 3 area 0 okay, this is the neighbor adjacency with R4 NAT. Okay, this exit or no passive interfaces exit. And now configure R1. Enter enable configure terminal configure terminal router OSPF1 do show IP route connected. Advertise routing on area 0 network 192.168.15.0 wildcard area 0 and the neighbor adjacency with R3. Okay, enter. Gigabit 00 will be configured on RIP. So for OSPF will be passive. So set passive interface gigabit 00. Okay. Exit and configure RIP version 2. Router RIP version 2. No auto summary. And advertise this network. This is loopback interface with advertise this 172.16.10 network 172.16.10. okay, 172.16.10. enter. And the passive interface for RIP is CL000. Passive interface for RIP is CL000. Okay, then exit. Now this side is RIP, this side is OSPF. So redistribute RIP and OSPF on this router, on this router. Okay. So access router OSPF1 router OSPF1 redistribute RIP. Okay, redistribute RIP and set a metric, for example 200, and include subnets. Okay, enter. Now you redistributed RIP in OSPF. Now exit and access RIP router RIP redistribute OSPF. And redistribute OSPF, the number of process of OSPF is 1. Okay. You can set the metric or press enter. Okay, press enter. Exit. Okay, go to R2. Enter, enable, configure terminal router OSPF1 do show IP route connected. Okay, advertise 23 for OSPF network. This 192.168.23.0 wildcard is 3 in area 0. Okay, the neighbor adjacency with R3 and gigabit 00 will be passive for OSPF, and sub interfaces on gigabit 01 will be passive for OSPF. Passive dash interface gigabit 00 is passive, and all sub interfaces, because it will be configured this side with EIGRP 0.1.40 50 60 199. Okay, 5 passive interfaces. Okay, and exit. Configure RIP for this side for 172.16.1. Router RIP version 2, no auto dash summary network. Okay, this 172.16.10, 172.16.10 wildcard, and no wildcard. Okay, and only the network. Enter, exit, and redistribute RIP into OSPF. So access router OSPF1, redistribute RIP metric 200, include subnets, exit, and go to RIP, router RIP, redistribute OSPF process 1, redistribute. Okay, very nice, exit. And now advertise this on EIGRP on gigabit 01. Okay, router EIGRP 100, EIGRP 100, and do show IP route connected. Advertise the networks of VLANs for the 5060 199. For the 5060 199. Network 172.16.40 wildcard. Okay. For the 5060 199. Okay, and set the passive interfaces will be gigabit 00 and serial 000. Interface gigabit 00, passive interface, passive dash interface gigabit 00, and passive interface gigabit 00 and serial 000. Okay, and exit. And don't forget to set the passive interfaces for RIP, router RIP passive interface. Okay, the only active interface is gigabit 00, so passive will be serial 000, that is on OSPF. Okay, serial 000, and also the sub interfaces on gigabit 01. Okay, gigabit 01, the sub interfaces for the 50, 60, and 199. Okay, exit. Now redistribute redistribute EIGRP into OSPF. Okay, router OSPF1, redistribute EIGRP 100, set a metric of 100, include subnets, enter. Okay, exit. Now redistribute OSPF into EIGRP, router EIGRP 100, redistribute OSPF process 1. Okay, set the metric, question mark, the bandwidth, you can use 10,000 or 1,000, question mark, delay metric on in 10 microseconds units, so you can use 100, question mark, reliability, the highest 255, where 255 is 100% reliability, reliable, question mark, effective bandwidth metric. Okay, the loading, so 255 is 100% loaded, so you can use one. Question mark, the MTU 1500, enter. Very nice, exit. Okay, and now redistribute EIGRP into RIP. Okay, router RIP redistribute EIGRP 100 question mark, set the metric, for example, okay, that is enough. Router RIP redistribute EIGRP 100, enter, and exit. And now redistribute RIP into EIGRP. Router EIGRP 100 redistribute RIP question mark, set the metric question mark, bandwidth 10,000 for example, question mark, delay 100 question mark, reliability 255 question mark, load 1 question mark, MTU 1500, enter. Very nice, exit. Okay, and show running config. Okay, this is EIGRP redistribute RIP and OSPF. This is OSPF redistribute RIP EIGRP, and this is RIP redistribute EIGRP and OSPF. Look at the networks, the advertised networks, passive interfaces, and redistribution on EIGRP. On OSPF, passive interfaces, advertised network, only one, and redistributions. And RIP, passive interfaces, the advertised network, and redistributions. Okay, and to verify, go to R6 and enable show IP route. Okay, for example, on R6, external 2 because it's redistributed by RIP and it's 172.16.1.0, 172.16.1.0, interarea 10.20.30 99. This very good. External 2 40, 50, 60 and 199. This of EIGRP, the redistribution, directly connected network, interarea 13, 23, 34, 45, 13, 23, 34, 45, and the default, the propagated static route. Okay, the propagated static route to connect internet. Okay. For example, go to R2, show IP routes. One, two, three, four, 5, 6, 7 directly connected networks. 1, 2, 1, 2, plus 4, including the loopback. 7 directly connected networks. Okay. And interarea 10, 20, 30, 99, 10, 10, 10, 20, 30, 99. And interarea 56, 31, interarea 56, 31, and OSPF 13, 34, and 45. 13, 34, 45. 23 is directly connected network. And finally, verify on R4. Enter, enable, show IP routes. Okay, all the networks, very good, very nice. The static route here, the connection to internet, very nice. Okay, and now configure the switches here. Okay, I will start with this S5. Enter, enable, configure terminal host name S5. Gigabit 01 should be trunk. The gigabit 01 switch port mode trunk. Okay, and use the NAT VLAN 99. Switch port trunk NAT VLAN 99. And create the VLANs and exit. Create the VLANs 30, 20, 10, 30, 20, 10, and 99. VLAN 10, VLAN 20, VLAN 30, VLAN 99. Exit. And assign fast Ethernet 1 to 30. Fast Ethernet 1. Switch port mode access. Switch port mode access. Switch port access VLAN 30. Number 2 to VLAN 20. Okay. 3 to VLAN 10. 3 mode access VLAN 10. Then exit. So that is enough. This switch S7, no VLANs here, only one network. Okay, S1, no VLANs on S1. Now configure S2, S3, and S4. Start with S3. Enter, enable, configure terminal host name S3. And set the trunks gigabit 01, interface range gigabit 01, 23 and 24, fast Ethernet 23 and 24, and 21, 22, and 20. Okay, 20, 21, 22. So from 20 to 24 and gigabit 01. Okay, from 20 to 24, that includes 20, 21, 22, 23, 24, and gigabit 01. Okay, also include the gigabit 01. Enter switch port mode trunk. Okay, switch port mode trunk and use VLAN 199. Switch port trunk native VLAN 199. Enter. Exit. Okay, but create the VLANs on the switch 40, 50, 60, and 199. VLAN 40, 50, 60, 199. Exit. 40, 50, 60, 199. Okay, you will see this message native VLAN mismatch because S3 is using native VLAN 199 with S2, but S2 and S4 are still using the native VLAN by default, the number 1. So for now, there is a native VLAN mismatch. So go to S2. Enter, enable, configure, terminal, host name, S2, enter. And 23, 24, 23, 24, and 19. 19, 18, and 17. Okay, the interface range from 17 to 19 and 23 to 24. Okay. Uh, 19, 18, and 17, and 23 and 24. Okay, 17, 18, 19, and 23 and 24. Enter. Okay, interface range from 17 to 19 and 23 and 24. Enter. Switch port mode trunk. Okay, switch port mode trunk and switch port trunk space native VLAN 199. Very nice. Exit. Okay, consistency restored, but create the VLANs here. VLAN 40, 50, 60, 199. Okay, then enter, exit, and now configure S4. Okay, but don't forget to assign fast Ethernet 4 to VLAN 40. Interface fast Ethernet 4, switch port mode access, and access VLAN 40. Okay, and now configure S4. First, configure the trunks. Enter, enable, configure, terminal, host name, S4. Interface range for trunks, and 20, 21, 22, and from 17 to 19. From faceta 17 to 19, and from 20, 21, and 22. 20, 21, and 22. Okay, so from 17, 18, 19, 20, 21, and 22. Okay, enter. Okay, from 17 to 22, switch port mode trunk, switch port trunk, space native VLAN 199. Okay, port consistency restored. Okay, the range, the trunk, and native VLAN 199. And don't forget to set fast Ethernet 4 to 40, fast Ethernet 5 to 50, and fast Ethernet 6 to 60. Interface fast Ethernet 4. Switch port mode access, switch port access, VLAN 40. VLAN does not exist. Okay, creating. Okay, don't worry. Fast Ethernet 5 mode access to 50. And number 6 switch port mode access, VLAN 60. Exit. So VLAN, create the VLANs VLAN 40, VLAN 50, VLAN 60, and VLAN 199. Exit. Okay, create. Don't forget to create 40, 50, 60, and 199 VLANs on the 3 switches S2, S3, and S4. Okay. Now configure this access point. And port 0 is the cable, port 1. Use this SSID CCNA exercise. Okay, CCNA dash exercise. Case sensitive, and use WPA PSK security WPA2 reshared key, and use this password. Use this password. CCNA dash exercise lowercase. Okay, exercise. Okay, very good. And go to the laptop. Desktop, wireless, connect. And wait a moment. CCNA exercise, connect. The password CCNA dash exercise lowercase connect. Now you are connected. Very good. And you need to configure an IP address. But, all VLANs with DHCP service. Okay, so create R6 should be the DHCP server. So that's why it has the number DHCP. So you can create the pools for the VLANs. Okay, R6 DHCP. And on R6, create the pools. Enter, enable, configure, terminal, IP, DHCP, excluded dash address. Okay, exclude address from the fields 172.16.10, 172.16.10. From exclude from 1 to 10, 172.16.10.10. Okay, for 20 and for 30. Okay, for 20, 2020, 21, 2010, and for 30, 31, 3010. And also you can create for 99, 9910, 99.1. Also for 40, 50, 60, 199, 40, 50, 50, 60, 60, 199, 199. Okay, 8 pools, 2, 4, 6, 8 pools. and create the pools IP DHCP pool. You can set VLAN 10 this name for this VLAN 10. Enter the network, 172.16.10.0 and 255.255.0. The default router 172.16.10.1, and use a DNS. The DNS server will be this DNS server 172.16.30.254, the DNS server. DNS server 172.16.30.254, 172.16.30.254. Enter. Okay, very nice. And VLAN 20, network is 20, default router 20.1, DNS server the same, 30.1, the same DNS, 40.1 DNS, 99.1, same DNS, okay, 10, 20, 30, 40, 99, okay, 10, 20, 30, 40, 99, 50, 60, 199. 50, 50, 50, same DNS, 60, 60, 60.1, and 199. Okay, exit. Okay, and review 172.16.40, 50, 60, 199, 172.60, 20, 30, 99. Okay, excluded addresses for 8 networks, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, and configure the helper on sub interfaces on gigabit 00, and set the IP address of gigabit 00 on R6. Okay, show running config, to show running config. This is the IP address of gigabit 00, 172.16.56.2, 56.2. Okay, on sub interfaces on gigabit 00, configure helper address, enable configure terminal interface. Okay, gigabit 0010 IP helper address 172.16.56.2, the IP address of gigabit 00, the DHCP server. Okay, okay, also on 20 the same, on 30 the same, with 99. Okay, 10, 20, 30, and 99. 99. Okay, exit. Okay, but these servers will not use DHCP. These servers will use static addresses. If you will add a PC, we'll get the IP address automatically. Okay, and configure the helper on gigabit 01. Enable configure terminal interface gigabit 01 sub interface 40, 50, 60, and 199 for the IP helper dash address 172.16.56.2 172.16.56.2 enter 50 enter 60 enter 199 enter exit. Okay, so go to PC, go to the laptop, DHCP, very nice, PC1, very good, PC2, okay, PC3, DHCP, very nice, laptop, wireless connection, okay, fast Ethernet 9 should be on VLAN 199, fast Ethernet 9 mode access VLAN 199 exit. Go to the wait for the green indicator here, wait a moment. Okay, wait for the green indicator. Okay, got static DHCP on the laptop with wireless connection and very nice. Configure these PCs for with static IP 172.31, for example 11, 255, 255.0, default gateway 1, and 172 DNS 172.16.30 to 54, 172.60.30, 172.16.30 to 54. Okay, very good. Okay, 172.16.30 to 54. The DNS server, configure static addressing 172.31.12, subnet mask 24, default gateway is 1, DNS server 172.16.30 to 54. Configure the static addresses on the servers 172.16. Okay, the DNS is 30 to 54, subnet mask 24, 31, the default gateway 30 to 54, the server itself, TFTP server 20.254, 24, 20.1, 30.254, DHCP server 10 to 54, 24, 10.1 30.254. Okay, very good. And configure this PC uh, 1, 11, 24, 1, 1, 30.254. Okay, and this another pieces 111, 255, 101, 30.254. This another PC 112, 24, 101, 30.254. Okay, this server on internet 209, 165, 202. Subnet mask 29 is 248. And default gateway 209, 165, 203. The default gateway is this interface on gigabit 01. Okay, DNS server, and you can use the 172.16.30.254 or another server because this is on the cloud. So maybe we'll not use a server on a private IP address. This should use a server on the cloud on internet. So I prefer to remove this. Okay, and now configure this connection, the DSL modem, go to the cloud, and set a relationship between Ethernet 6 and modem 4. Configure and go to DSL modem 4 with Ethernet 6 and add. Now you have the relationship. So this PC will be able to ping the gigabit 01 interface on R4 NAT. Okay. Ping from server 209.165 200 to 3. Success. Okay, now this configuration of the internet cloud is very good. No configurations on the modem. Very nice. Okay, now OSPF 1 ready, EIGRP 100 ready, RUI version 2 ready, server farm ready, all VLANs with DHCP service ready, Etherchannel. Okay, configure Etherchannel here. Etherchannel here, 23 and 24 on these switches. S3. Enter enable, configure terminal, interface range, facet NAT 23 and 24, channel group. For example, channel group 1 mode for LACP should be active. Active in this side, active. Okay. Exit on the another side on S2. Enable, configure terminal, interface range. The same ports, facet NAT 23 and 24. Okay, 23 and 24. Channel dash group 1 mode passive. Okay, exit. Then here on S3 ports 20, 21 and 22, enter interface range 20, 21 and 22. Channel group, use another number 2 mode, and configure port aggregation protocol. Okay, port aggregation protocol, and should be mode desirable. Okay, desirable, enter. Okay, the another option is auto. Okay, but I'm using desirable. That is enough. Okay, exit and go to S4 20, 21 and 22. Enter enable configure terminal interface range fast Ethernet 20, 21 and 22. Channel dash group 2 mode desirable. Exit. Okay, channel group 2 mode desirable. Okay, and S3 channel group 2 mode desirable. Finally, this link on and S2 interface range 17, 18, 19, from 17 to 19. Channel group, another number 3 mode on. Okay, exit. The same range on S4, enter interface range 17, 18, 19. Channel group 3 mode on. Okay, exit. Very nice. Okay, Ether channel ready, wireless ready, TFTP server ready, DNS server ready, NAT and path. Okay, configure NAT on the on R4. Okay, but before to configure NAT, verify the connectivity. Go to this PC, PC6, and ping another PCs. Ping laptop IP address is 40.11 172.16.40.11. Okay, enter. Okay, this is not working, will fail because you need to configure HSRP here. Okay, because the interface gigabit 00 on R1 enable show running config. Gigabit 00 has the address number 2, and on R2 enable show running config. On R2 gigabit 00 has the number 3, so the default gateway is 1, and this ping will fail. So configure HSRP. Okay, configure this HSRP. It's not in the list, but anyway, configure HSRP. And configure on gigabit 00 on R1, 00 on R1, space configure terminal interface gigabit 00. Standby. Use group number 1, any number, and the virtual IP. The IP will be 172.16.1.1, the virtual default gateway. Enter and set the preempt. Okay. Verify another options. The priority in another, and I will set the priority on R2. Okay, that is enough. Exit. Go to R2. Configure terminal interface gigabit 00. Standby group number 1 IP 172.16.1.1. And set standby group number 1 preempt and set the priority higher than 100. The default is 100 priority. So you can use 120 for a better priority on R2. And now go to PC6, ipconfig, look at the default gateway now exists as the virtual IP for HSRP, and ping the laptop, this laptop. Okay, review R1. Okay, very good. R2, very good. Okay, this is a weird behavior, this blinking links, blinking indicators with high frequency. This is a weird behavior. Okay, and to avoid this, save the changes, save, close the packet tracer file. Yes. And open again, open again. Okay, but wait about 3 minutes for the network convergence. Okay, about 3 minutes for the network convergence. Okay, go to PC6, desktop, command prompt, ping this PC, this laptop. Okay, wait a minute to receive the DHCP configuration. Review the another pieces. This is okay. Okay, very good. Laptop. Okay, static DHCP. Okay, very nice. Is now is 40.12. So ping to 40.12, 172.16.40.12. Success. Now this PC1 is the destination 40.11. 40.11. Success. The PC number 2, 50.11. 50.11. This is another PC number 3, 60.11. And this laptop with wireless connection, 199.11. 199.11. Success. And this server 30.254. 30.254. Success. The another server 20.254. And DHCP server 10.254. 10.254. And PC7 30.111. 172.31.11. Success. And PC8 30.12. 30.12. Very nice. Finally, the web server 209.165.202. 209.165.202 to internet. Success. Okay, the ASA network is not configured, but OSPF ready, EIGRP ready, RIP ready, server farm ready, all VLANs with DHCP service ready, Etherchannel ready, wireless ready, TFTP server ready, DNS server ready. Now configure NAT and path. Configure here NAT and path. Enter, enable configure terminal. Okay, first create the port address translation path. First create the access list. Okay, access list number 1 permit, and permit summary network for all the private networks here. I think is 172, and 192 also use it for routers 172.16, 172.30. Okay. 172.16.1, 172.40.50.60, 172.30, 2010, 172.30, 172.16.100, 192.168. So you can include the on R4 NAT you can permit 172.16.00 with this wildcard 00.285.285. Okay, all networks of 172.16.00 and all networks of 172.30. Okay, 172.30. Okay, in the same wildcard. And also, if you want, you can permit the 192.168. Okay, don't worry, that maybe should be useful. 192.168.00 with the same wildcard. Okay, and at the end, implicit line deny any. Okay, then access exit or IP inside IP NAT inside source list. Now I'm creating the path port address translation. IP NAT inside source list. The list is number one, and interface. The exit interface is gigabit 01, and overload for port address translation. Enter, and gigabit 01 is the exit interface gigabit 01, IP NAT outside, if is the exit is outside, and all other interfaces like serial 000, serial 001, and gigabit 00 are inside. Gigabit 00, IP NAT inside, serial 000 inside, serial 001 inside, exit. Very nice. And now path is ready. Configure NAT. So you can configure NAT, static NAT for one server. For example, the TFTP server. You can create a public IP address for this. Okay, and should be in this range. Okay, and for example, add here public IP. Public IP 209.165.200, 2 and 3, and use. You can add 4, for example. Okay, you can add number 4. So you can use IP NAT inside source static NAT, and question mark IP NAT inside source list. The inside is this. Okay, 20.254, 172.16.20.254, and the outside 209.165.204. Okay, 209.165.204. Enter. Okay, inside and outside interfaces are set. So go to web server, and you can ping the TFTP server, but using the public IP address 209.165.204. Success. So go to R4 NAT and show IP NAT translation. You can see the translation for the inside global 4. The inside local is 20.254. The outside local is 2, the web server, and also this is the web server. And to verify path, you can go to PC6 and ping the web server on internet success and verify R4 NAT, show IP NAT translations. And now you can see 172.16.111 is this PC6 IP config. 172.16.111, okay, here should be 11. And is translated to 209.165.203. The IP of the interface of gigabit 01 on router R4 NAT. Okay, and this is the IP address of the web server. Okay, so path and NAT ready. Static routing ready for the connection to internet. Inter-VLAN routing ready here on VLANs, and router. And access list. Okay, an access list is created here for NAT, but you can create another access list for security. Okay, now for example on R6 you can create an access list. Okay, go to R6 and create an access list. Enter enable configure terminal IP access list. You can this is a named access list and will be a standard access list. Will be security. Okay, and permit. Okay, permit this PC7. The IP address of PC7 is 172.30.111. Permit host 172.30.111. Okay, 30.111. Okay, enter. Then, okay, here there is at the end there is implicit deny any exit, and configure the SSH configuration. The host name is already configured. Configure a domain name, IP domain dash name. NAT net1.com. Enter. Create a crypto key, generate RSA general keys, general dash keys, modulus 1024. Okay, very nice. Create a username for SSH access, admin with the secret password, admin1pass, and configure IP SSH version 2, and configure the line BTY 0 to 15, login local to use this local username, and transport input SSH, exit. Okay, only SSH connections. Okay. Okay, I will document here SSH access with user, admin, and password, admin1pass. Okay. Here document in the router here. The IP address of gigabit 01 on the router show running config gigabit 01. 172.30.11. Okay, but okay, very. And now create the access list on line BTY 0 to 15 access dash class. Remember the name of the access list is security case sensitive uppercase security in. Okay, exit. So try to access from PCA SSH client and 172.30.11 username admin connect. Yes, has closed. The current session has closed. Okay, yes, okay, no. And try to access from PC7 again. Telnet SSH client 172.30.11 admin connect admin 1 pass R6. Very nice. Okay, it's working very well. So the access list is ready, and configure the VPN GRE tunnel. Okay, configure this tunnel and configure a tunnel. Okay, between R1 and R2. Okay, configure that. Okay, go to R1 and create the interfaces. Enable configure terminal. Interface tunnel 0. Okay, tunnel source. The source, you can use this interface serial 000. Tunnel source is interface 000. Enter, and the tunnel destination. The IP address of serial 000 on R2. Okay, on R2, enable show running config serial 000 23.2 192.168.23.2 192.168.23.2. Okay, tunnel mode GRE IP. Okay, and set an IP address. Okay, and for the tunnel, you can use an IP address of 172.16.99. 1 in this case, so not 255, 255, 255, 0. Okay, so this tunnel should be 172.16.99.0.24. Okay, and review more questions, review more options with more question. Tunnel source, tunnel mode, IP address. Okay, that is enough. Exit. And similar configuration on R2. Configure terminal interface tunnel 0. Tunnel source. This interface serial 000. Tunnel destination. IP address of serial 000 on this router on R1. Do show running config serial 000 13.2 192.168 13.2 tunnel mode GRE GRE IP address 172.16.99, number 2, 255.255.255.0, exit. Okay, the interface is up, exit, and you can ping the another side in the tunnel 172.16.99.1, success. Okay, and tunnel ready. Now, only the ASA configuration is missing. Now, configure ASA interfaces, ASA 5505, command line interface, enable, password, no passwords, press enter, and configure terminal. Configure interface VLAN 1, okay, set an IP address for Ethernet 01 with this layer 2 interface, so you need to create interface VLAN 1, interface VLAN 1, and set an IP address on this network 100.172.16.101, subnet mask 24. Okay. Okay, interface address is not on the same subnet as the DHCP pool. Okay, and verify show running config. Okay, Ethernet 00 on VLAN 2. Interface VLAN 1. Okay, this is already interface VLAN 1 already set with an IP address. Space the DHCP. Okay, okay, and remove these configurations. Okay, right erase, remove all these configurations, enter, confirm, enter, and reload. System configuration has been modified. Save? No. Okay. Pre-configure firewall now? No. Enter. Okay. Enable password, no password, show running config. Okay. No configurations. Now. Okay. Configure terminal interface VLAN 1. Okay. And Ethernet 01 with Ethernet 01 is a layer 2 interface, so you need to create an interface VLAN 1 and set the IP address on VLAN 1 172.16.101 subnet mask 24. Okay, this subnet. I'm using the first IP, and the name of the interface, name interface inside. Okay, inside. And the security level, okay, the security level for inside is 100 by default, but anyway, security level 100. Okay, enter, and no shutdown. Now configure, and now assign Ethernet 01 to VLAN 1. Okay, and exit interface Ethernet 01, switch port mode access, enter, switch port access VLAN 1. Okay, exit, create another interface VLAN number 2. For this, another connection for outside interface, the connection to the router R4 NAT. the IP address 192.168.36. That what is the IP address of gigabit 00 on R4 NAT? Enable show running config 00.36.1. So use 36.2 on the ASA firewall. 255 because it's prefix 30 and enter name interface outside. Okay, outside 00 and security level 0. Okay, security level 0 because it's a public network. Inside this private network, so security is 100, higher than outside, that is 0. Outside in public network. Okay, outside in public network and security level 0. Not shut down to be sure it's enabled. And finally, assign Ethernet 00 to VLAN 2. Okay, interface Ethernet 00, switch port mode access, switch port access, VLAN 2. Very good. Okay, and exit. Okay, and create a default static route on ASA to reach all other networks, including internet and other networks. Route of outside. Okay, the static route in the outside interface and the default route. And the NAT hop IP address, okay, you know, is 192.168.36.1. The IP address on the interface of the router are for NAT gigabit 00, 192.168.36.1. Okay, enter. Okay, and okay, also in ASA you can create a NAT here on the outside interface, NAT. Okay, NAT. And you can use the following commands. Okay, and to configure a NAT, create an object network, and create a name, for example, inside-net. Okay, this is only a name. Enter. Okay, log off. Okay, enable no password. Enter. Configure terminal. Okay, create a object network inside-net. Okay, and this is the inside network 172.16.100.0.24. Okay, and the subnet 172.16.100.0.24 is 255.255.255.0. Okay, this line. Enter. And create a NAT. Okay, create a NAT, and from inside to outside interface. Okay, from inside the source to outside the destination. Inside interface, outside interface. And configure dynamic interface. Okay, enter. Okay, very nice. Exit. Okay, from PC4, command prompt ping ipconfig, ping the default gateway that is the inside interface on ASA, ping 172.16.101 success, and try to ping the IP address on the router. Try to ping 192.168.36.1 okay. Try to ping this interface on the router R4 NAT, okay, and this ping will fail because firewall is blocking ICMP. Firewall, ASA firewall is blocking ICMP messages. Okay, so I will permit ICMP messages. I will permit on the firewall, so configure ASA, configure terminal, class dash map inspection underscore default. Okay, enter, and match default dash inspection dash traffic. Okay, inspection traffic. Very nice. Exit. Configure the policy dash map and configure the global underscore policy. Okay, policy map global policy. Okay, and class, the class is inspection dash default. Okay, underscore default, because it's this. Now inspect ICMP and inspect HTTP. Okay, for ping ICMP and for web service HTTP. Enter. Very nice. Then exit. Okay, and set the service dash policy global underscore policy global. Okay, this command, enter. Very nice. And now go to PC4 and try to ping the default gateway. Very nice. And try to ping the IP address on the router. Very nice. Try to ping internet, the web server, ping 209.165.202. Okay, the connection to internet to the web server. Success. Very nice. Okay. OSPF ready, GRE ready, ready, servers ready, VLANs with DHCP ready, Ethernet channel ready, wireless ready, TFTP ready, DNS server ready, NAT and PAD ready, static routing ready, inter-VLAN routing ready, access list ready, VPN GRE tunnel ready, HSRP ready, ASA configuration ready. Very good.